Or ready to go. Good afternoon. Thank you for showing up at 5 p.m. on day 2. I know it's been 2 busy days, so I appreciate you guys showing up. And I know I'm probably the last one between you and the Circle Ranch party, so we'll try to make it worth your while. My name is Saurabh Mishra. I lead product strategy within our IoT and Industrials group. And the topic of my presentation is the anatomy of an enterprise AI agent. Now, we've talked about AI agents multiple times in this conference. So my goal is to kind of take it a little bit high level, really focus on what enterprises are looking for in an agent, start with characteristics, start with components, and then we'll talk a little bit about an application that we recently launched, SAS Retrieval Agent Manager, and we'll walk through how Retrieval Agent Manager or RAM supports that with a use case example in mind. Okay? So let's get going. So we're starting to see this evolution that enterprises are starting with AI experiments, but ready to move towards enterprise-ready AI. So the evolution that's happening is, a number of components coming together. You start with RAG, agents, multi-agents, ultimately getting to a system view of a problem, of a workflow that they're trying to drive. So this is what we're going to dive into. But before we get too far into the weeds with what are the components, what makes a good agent, let's talk about what is the gap that exists between AI capabilities and what enterprises are looking for. So when we start to think about agentic AI, generative AI, the thing that comes to our mind is the language models, the large language models. And these are great. These are important and critical component of agentic pipelines. But if you think about what the models are doing, models are supporting, they're optimized for answers. Enterprises expect outcomes. Models are probabilistic. Enterprises are looking for deterministic and repeatable results. Models are intelligence without any context. Enterprises need grounded responses, so context is important. Models are isolated on their own. Enterprises require a systematic integration. And models, the responses can be opaque. And with enterprises, you want transparency and governance. So the goal is to go and focus on the system design. So the gap is not the model capability, it's the absence of a systematic design approach. So what does that mean? So I wanted to kind of talk about what makes an AI agent enterprise ready without using any 3-letter acronyms, without using any fancy language. Now, there's probably multiple variations of it, and if you search, you will probably find slides which define 50 characteristics. But in our experience, as we're starting to roll this capability out, working with partners and customers, these 5 things seem to stand out. So I want to just kind of talk about that. So the first key characteristics is that they need to be grounded in enterprise data. That's fundamental. That's table stakes. You need to be able to use trusted and governed data. So that's one. Enterprise agents need to be orchestrated because you're often following a logic, you're following a workflow. You need to be able to weave in multiple steps. So orchestration is really important. So it's no longer just asking a question and getting a response. It's a multi-step, complex pipeline that needs to be orchestrated. Enterprise agents need to be connected to systems, right? We often just jump into conclusions like, I need tools. You need tools because you need connectivity. So they need to be able to connect so that they can take actions via APIs, via code, whatever is the ultimate endpoint is. They need to be governed and observable, right? This is fundamental, and this is why it's an enterprise context that we're talking about. So agents need to have guardrails, traceability, monitoring, so that you can go back and answer the question of, why did I get this response? What can I change? They need to be consistent and cost aware. So you need to be able to follow a repeatable pattern. And everybody, I've been talking to several people here. They're like, I didn't realize that, some of these things add up from a token cost perspective. Well, they do, right? And that's really important to understand. Earlier in the day, we talked about how some of the optimizations that we have done in this application can make it more CPU friendly. So being able to have a cost awareness of it is really important characteristic of an enterprise agent. So these were the 5 characteristics that we came up with. And then we started to think about, okay, let's start to map this to the components part of it, right? If I have to achieve them, if I have to support this, then what are the components that I need to be looking at? So this is not in any particular order, but then we started thinking about components that make an AI agent enterprise ready. And now we will start to throw some three-letter acronyms, and hopefully some of these are familiar to you. On the top left, it's RAG. RAG is Retrieval Augmented Generation. I'm sure several of you are thinking about it, starting to experiment with it. The idea with RAG is really simple. This is what allows you to bring your unstructured data. It allows you to prepare this data. So you start to deal with terms like vector indices and embeddings. And then once your data is prepared, this is what supports retrieval against that data to bring that context. So RAG is important. MCP is next. MCP is the tooling infrastructure. So I talked about enterprise agents need to be connected. They need to be connected to a system. The way you do that is through MCP. So MCP is where you define tools against potentially your existing capabilities. These are your APIs. These are your databases that already exist. You need to be able to have local MCP and remote MCP. That's the only way you can drive enterprise-wide connectivity. And the way that the language models discover MCP tools is through a catalog, which lists the tools and the definitions. So it's really important to have a way that users can easily change it. The super users can easily manage these schemas and definitions. So that's MCP for you. Memory is another critical component. So you're talking about two types of memory. Really the session state, what's happening in a session, a particular chat session, so that as you continue to talk to an agent, it's kind of retaining that. And more of a persistent storage. So once you're done with it, you want to be able to save it so that when you come back, it's kind of, we talked about the consistency aspect, you want to be able to resume as needed. Agent orchestration, so we talked about orchestration earlier on. Depending on your use case, you need capabilities to be very explicit about workflow definition. So you do that. I'll show you an example. As agents get more mature, you can actually program them to be either React-based or plan-based. So we'll talk about that with an example. And orchestration is no longer limited to single agents. So you could have multiple agents that are coming together to perform a task. So how do you orchestrate that multiple set of agents is also an important aspect. The LLM is there. It's not going anywhere. Actually, it could be a smaller language model. So the language model is there. That's the general purpose intelligence layer. You need to be able to support both foundational models and fine-tuned models. And at some level, we think it should be provider agnostic. The goal is that you want to design these pipelines without getting tightly coupled to any particular model, so that if a better, cheaper one gets available, you're able to swap it out. And last but not the least, you need a control layer. This is where you start to think about guardrails and access control. Things like, who can create these? What can these agents do? What can they not do? Observability is another important area that we're looking at. So when the agent does come back with a response or a recommendation, you need to be able to open the pane and see what actually happened behind the scenes, what documents were consulted, what tools were called. Feedback loop, so that your users, once they get a response, they're able to indicate that this worked, this did not work. So that control layer is really, really important. The other thing that we are starting to see is that you don't necessarily need to jump into a multi-agent orchestration right away. So we started to classify a few design patterns that we're starting to see from a use case perspective. So we'll just go through this right now. The topmost is RAG. So as soon as you have RAG in your organization, you're able to prepare these documents. That gets you a certain level of value right there. So if your goal is to support retrieval, some level of synthesis, you can actually use RAG to get started there. These are, the applications for these could be knowledge assistant, policy, document Q&A. So that is something that's totally possible with RAG without even getting into the agent part of it. But if you need, your goal is to be able to reason, perform some action, and these are tasks that require decisions and tool usage, you need to start working with agents. Some applications are like you need to be able to update a system, you need to provide it a guided decision support. So that's where agents start to come in picture. And then as you go along this journey, if you're looking at creating a set of specialized agents that need to be coordinated to execute complex workflows, that's where multi-agent becomes a reality. And the applications are, again, cross-system complex workflows, which is, again, a very real enterprise requirement. So these are the design patterns that we're starting to see, which go from answering questions to actually orchestrating systems. I'm going to spend some time just talking about this multi-agent setup because it is a special scenario that we're starting to see. So in this case, we're talking about implementation of A2A or agent-to-agent protocol. So usually the scenario is that there is a supervisor agent, and we tend to call it the orchestrator, and then there are the specialist agents or delegate agents at some level. So there are certain things that are limited to the supervisor, and there are certain things that the specialist or delegate agents. So the supervisor agent has access to the delegate agents. It understands the skills of the delegate agents, and depending on the task or the goal, it can execute them. The supervisor agent on its own does not have direct access to any tools. That's why the delegate agents are for. Delegate agents are standard agents. They could be standalone agents. You can use them as a single agent on their own, but they are the ones who have access to tools to carry out the task. The delegate agents expose their capability through an agent card. This is how the orchestrator or the supervisor agent understands their skills and their capabilities. And when you are designing this at the orchestrator level is where you specify the plan mode, whether that's React or whether that's some sort of a plan-based logic. So the idea behind React is that it's more of an iterative process. So you give a goal to an agent, it'll use some reasoning and start the process. And as it gets a response, it'll continue to refine and iterate. And contrast that with plan mode, so you can actually say that I want you to do this in a plan mode. So before it does any calls, it'll come up with a plan and then go about executing. It's almost similar to how we humans perform. Some of us are more planning type, so you actually prepare a plan before you go do. Some of us are more spontaneous. You actually start to do something and then you react and refine. That's the same concept that we're talking about here. Orchestrator is what enforces some level of convergence, whether that's in terms of time, whether that's in terms of the limits that LLM has. But the idea is that your supervisor agents are not just limited to supporting an orchestrator. They are independent agents. They can run without supervision. But that's the idea that the orchestrator is able to call upon the right set of specialist agents depending on their agent card and the skills identified. OK, so this is now going to move into the second part of the presentation, where we'll walk through an example using SAS Retrieval Agent Manager. So before I get to the use case, I wanted to just map the components that I showed earlier with the capabilities that RAM has to support some of those components. So we have full support, as you can see. Anything with an asterisk is a roadmap consideration. Everything else is generally available today. So we have very deep support for RAG, which includes semantic and hybrid search against databases. We provide very deep level to evaluate these pipelines to make sure that you are coming up with the best configuration possible. We have full support for MCP. You can define using code. You can create your tools. If there are standard containers that are available, you can bring that inside to instantiate. We support execution of local MCP servers, and we also support connection to remote MCP servers. We support memory. Long-term memory is something that we're working on from a roadmap perspective. We have deep support for orchestration. So you can actually inject custom logic using Python if you want to bring very specific explicit orchestration. We provide tool selection at an agent level, so you can be very explicit and limiting that these are tools you can access and only these tools. And we support React and plan-based orchestration, the one that we talked about. And we have rich control layers. So we support evaluation at every layer. We provide citations with our responses and deep observability. So we show you every time what went in, including latency, including cost aspects. So that's where RAM is from a capability perspective. And as you can see, there's a few roadmap items that we continue to iterate with. But let's get back to the use case that I wanted to talk about. So this use case is something around social benefits eligibility. So at least in the US, many states have these programs like SNAP benefits. And there are case workers who are the ones who are actually reviewing applications as people are applying to avail the benefits of state programs. And as with many of these agencies, these case workers can be overworked. They are dealing with a lot of applications. So to actually make sure that there is a systematic way to kind of guide them and support them is the use case requirement here. So as you can see, Jane is our social benefits user here. And at the bottom, it shows a rough set of blocks around what the use case requires. So we need to be able to review applications, verify form data. We need to be able to prioritize the cases that social workers are working on. And we need to help them with interviewing them to make the right decision. Because unfortunately, there's also fraud involved in these cases. So let's just go through this. So in this case, the way we are going to tackle this is we created an orchestrator agent. So this is the supervisor agent. And at the delegate level, we have two agents. So one is dealing with my case load. So the case load agent has access to what applications are coming in. It has access to what level of prioritization is required, what complexity these cases have. So it can provide recommendation back to Jane. These are the cases to handle, and this is the application information that I have. The other delegate agent that we have is really a policy agent. So as you can imagine, a lot of this is very document heavy. So we have the policy agent that can inject all the policy information and able to provide recommendation as needed. So again, Jane can interact with both of them, but for the most part in this case, she's going to be working with the orchestrator agent. And when she's interacting with the orchestrator agent, it's transparent. She doesn't know, which agents are getting activated. That's all handled by the system. All right, so we'll just go through all the steps that are required to enable this pipeline. So again, we need RAG in this pipeline. So we have, like I talked about, rich support for RAG. We support native connectivity to a number of source systems. But if your documents are in some system that we don't have native connectivity, you can build your own. We support a number of embedding models. Some of them are preloaded. Some of them can be bring your own. And we have rich support for evaluation. So one of the challenges with doing RAG is that you can implement these pipelines, but you're making decisions. What is the right embedding model? What is the right chunking strategy? So evaluation is a way to test these pipelines and make sure that you're working with the best at any given time. So the screenshot on the right shows you two pipelines in action, and then after some level of compare and contrast, one of them was chosen as the champion pipeline. So that's RAG for you. And in this case, I'm just showing that for the social benefits one. So on the top right, you see a screenshot of the policy document. It's a dense PDF with hundreds of pages in it. And we were able to take that, and we prepared that in our system as a RAG pipeline and selected a champion configuration for it. OK, the next thing we had to do was create the appropriate set of tools. So this is where the MCP functionality come in. So in RAM, we can create tools either with code, or you can bring a container, like I mentioned earlier. So we support both of them, and we can connect to remote MCP servers as well. So for the purpose of this scenario, we had to utilize both of them. So we created some tools using Python, and these are tools like to fetch applicant info, to fetch pay stub information that the applicant might have provided along with the application. So those are the tools that were specifically created for this use case. But we also knew that we had to access databases. This is a Postgres database. So for these things, there are standard container-based MCP servers available. So we were able to use one of those without needing to recreate tools. So those are the two types of tools that we created for this use case. Now we come to the agent building part of it. So I have RAG, and I have the tools, right? So I'm ready to build agents. So this is where you actually go through a user interface that is shown on the right to build agents. In agent building, you actually select, what tools can the agent access, what are the documents that the agent can access. And just like RAG pipelines, there is not a golden rule. So you know exactly what tools, what documents. Sometimes there is an experimentation aspect here, so which is exactly what the workflow supports. So we allow you to create experiments and have a super user specify some success criteria. Like, how do I know that this particular agent is doing what it's supposed to do? So once you do that, that's the experimentation part, and you're able to designate them as the champion agent experiment, which becomes the go-to configuration for the next step. Optionally, you can inject custom code. You don't have to, but if there's some explicit logic required that need to be brought in, you can do that with Python. So in this case, we created, like I said, two delegate agents. So these are the two standard agents that we created. So there is a case load agent, and there is a policy agent. So on the left is the agent card for the case load agent. You can see some of the skills. It knows case prioritization. It can provide summary information for a particular application, and it can help with interview question generation, so that when the caseworker is actually interviewing, they are ready with the right questions. On the right is the policy agent. Policy agent is essentially a RAG-based agent. It supports documentation search against a policy document that we saw earlier. So those are the two delegate agents that we have. All right. So now let's talk about orchestration. Right? So now I'm going to be orchestrating these two agents as needed. So how do we enable orchestration? Creating an orchestration agent is just like creating another agent. The difference being that instead of selecting tools, you are selecting delegate agents. So as you can see on the right side, in this case, the orchestrator selected 2 delegate agents, which were the 2 agents that we created earlier. So the social benefits case load agent and the policy agent. So it selected those. And once again, you are able to bring custom logic here if needed at the orchestrator level as well. And once you are ready with your orchestration, you can designate the plan mode, whether you want to do the react thing or planning first, like we talked about earlier. So this is the orchestrate at the beginning of the orchestration part. And as you go through this, you are making several selections. So on the top right, you will need to select the orchestration type. So basic is really the react one, where it starts and then iterates. And then you could also choose a planning orchestrator option, where it creates the plan. On the top right, you have to select an LLM. So that's the other decision you are making. As you are experimenting, you may try different LLMs and see which one works better. So we allow you to mix and match LLMs. And then, obviously, you have to select your delegate agents. That's well and defined. I have 2 delegate agents that I'm going to be selecting here. So I got that part ready. And then this is the orchestration mode. So I wanted to give an example of what it looks like without doing the plan mode and with the plan mode. So it's probably hard to read, but this is how we see the observability. So once an agent is actually up and running in action, you're able to, at any given time, ask a question. Like in this case, I asked, can you help me with Amy's case? And I'm able to see, OK, what is it doing to actually provide a response? So in this case, it starts with a tool call on the left side. Just makes a tool call, gets a response, and then it can iterate. So that's where the reasoning comes in. So that's the React model. On the right side, it's actually doing some planning. What am I going to do first before it makes any calls at all? So there is a difference between the plan without plan mode and plan mode. And this is part of the experimentation. This is what you need to try out before you say that this is my champion configuration. So once we have defined our agents, you are ready to run them. Right? So we actually execute our agents in local cluster. We are actually able to put each agent in a separate container. So there is some level of isolation. That is also good from a resource perspective. You are actually able to constrain the agents that this is the amount of resource that's available to you so that you actually can dedicate resources for all agents in your cluster. The way you use these agents is through, so we have a chat layer. You can actually start to use the chat layer to interact with the agents. But we also have an API layer. So if there is a need for you to connect to another application, another workflow application, some in-house application, then that's how you would interact with these agents. And for every response that we generate, once again, we'll give you a full trace. This trace is available in our UI, so you can look at it. You can understand the sequence of steps that happened. We show you the cost and latency. But we also allow you to export this trace, because this has become a specialized area where people are reviewing the trace information that's generated by agents to really understand their behavior. So we allow you to export this. We use open telemetry format that is supported in many other systems that are specialized for this kind of analysis. And I think this is probably my last slide, but this is where we are showing how to chat with agents. So in this case, on the left, we got a response. It's providing an assessment of this particular applicant, Amy, and it's providing some level of information. What's the priority level? What are the key issues that it saw? And what are the action items that it's recommending to the caseworker? And as you can see on the right side, for the response, it gave what was the total duration of the response. It breaks it down, where it consumed more time, and same thing on the cost side. So just to kind of net it out, we talked about enterprise AI is a system design problem, not just a model problem. So it's really important to manage your data, tools, and orchestration, not just focus on the model capability. Agents are moving AI from answers to outcomes. So it is a journey that I think everybody will be taking at some point in time. So by combining some of the components that we talked about, you are able to get to just using LLMs to provide an answer to actually having these agents execute an outcome. But to be able to actually scale, it requires governance and control, not just intelligence. So we believe some of the guardrails the observability, the ability to control agents is fundamental to achieving the scale that we need here. And that is it. And that's my contact information if you are interested in connecting with me. But I think we might have a few minutes for any questions. Thank you. Yes. So the question was, do we have a library of agents, and how does orchestrated agents actually gets to know about the delegate agents? So we don't pre-build or ship any agent library, but the idea is that that's an enterprise function. So as organizations are adopting tools like this, they will start to develop their agents, and the goal is to develop the agents in a way that they are repurposable, so that they can be repurposed across departments, across different groups. And the way orchestrator agents discover the underlying agents is essentially through the agent card. So every agent has an agent card which lists his skills, and you as a user can review that and then assign that this orchestrator has access to these delegate agents. That's something that we can look at. I mean, I think there are options that we've considered in the past to provide some examples, some helper cases. Like, for example, writing MCP tools is another area where we have some preloaded tool examples that we've considered shipping. So that might be worth it. It's just that it's so use case dependent that it's hard to come up with an example of an agent that just works in every scenario. But I think that's a good idea. We can look at a GitHub-based approach to kind of make that accessible. Yes. No, they do not. So the question was, do all agents need to run on the SaaS server, SaaS ecosystem? So we actually have a fair bit of flexibility on the deployment side. So we would deploy in your tenant, whether that's in cloud or whether that's on-prem. So we actually support Azure and AWS as our cloud providers, and we can deploy on-prem. In fact, we've been doing some work with Intel and Red Hat to make sure that on-prem deployments are easy and performant. But the answer is that you're not limited to the SaaS ecosystem. You can deploy it pretty much anywhere that you want. So it's possible, but there's some security implications. So as long as we can actually enable authentication so that your orchestrator agent can get to the delegate agent, that's possible. But there is definitely some security considerations that we have to figure out, because we authenticate the agent calls. Yes.
Already working on the SaaS Via platform and wants to integrate like an agent with CAS or with the flows or with everything that they are doing, like in Model Studio, in SaaS Studio. Is that possible? And if yes, how is that possible?
So there is, it's possible today with APIs. So we have scenarios where if you're working in Via, let's say if you're using a tool like intelligent decisioning, and that's where you're creating your workflow, and you need to make a call into, let's say, what I was showing with RAM, either for a retrieval call or you have a specialist agent there, that's possible with APIs today. So that's something that we're doing. But we're also looking to integrate these capabilities that I talked about within RAM into Via. So that's an ongoing execution. The first phase is focused on the RAG part of it, but we would eventually get to the tools, agents, and multi-agent as well. Thank you. Okay, thanks everyone. Hope you enjoy the party.